Alright, so guys, today, new recording spot on the third floor. Now that doesn't matter, alright? Today, we're gonna learn about electricity and circuits, alright? Electricity is very, very important in our daily life. Electricity is everywhere, actually. So, there's two types of electricity, though. Static and flow electricity. I don't know what the name of the other one is. Static electricity, well, basically it's energy that, you collect protons into a area and then you discharge it somewhere else. For example, if I wore socks and I went on the carpet and I rubbed my feet on the carpet with socks on, then static electricity will get into my body, and if I touch someone, it will transfer the energy to them, giving them a little, right? And well, static also counts for electricity because a lot of protons get up in the air and then it needs to discharge, so that's electricity for you. But that's thunder and lightning, not electricity. And then there's flow, which is basically it's controlled, alright? So think of it like this. Let's say that you have a wire, simple circuit, and then you have an on and off switch, a light bulb, and a little wire connecting them. So if you turn it on, the electrons will flow, alright? It will flow, will be forced out of the battery and flow to the light, alright? But that's if the wire is closed, which means it's connected. But if it's open, which means when you're not connected, then the light will obviously not turn on, because even though energy is being given out by the battery inside the on and off switch, it isn't reaching the wire, which is actually going to transfer energy into the light. And while you use light bulbs stuff all the time, however, of course, wires, there's also two types of wires. For two types of electricity, there's two types of wires. There's parallel and circuit wires. Circuit wire basically, let's say a long line of light bulbs. Right? You turn one on, it will turn everything on. All right, because think of it like this. All right, one light switch, it will turn on the lights, the air conditioning in your home, the television. Right, basically anything that isn't a parallel circuit, it will all turn on with one switch. All right. So that's a problem because number one, that's inefficient, and number two, if you just turn off, if you break one of them, all of them turn off. All right. That's the problem, because one of them breaks, you can't use anything else. That sucks, which is not good. Now, parallel circuits, theoretically, they use a lot more wire, and they're expensive. Yes. But, let's say this, alright? Line, there's 3 wires, alright, connecting the 3 light bulbs. Those are parallel, alright? If, let's say light bulb A goes out, then light bulb B and C will continue going, because, even though the electrons can't flow into light bulb A, you can still flow to light bulb B or C, because it has choices now. Well, another thing that's also parallel circuits is that, the lights will basically remain the same, right? The more light you put, the more dim it gets, because it's spraying the electricity out into the light bulbs. Because you put 2 light bulbs, it will be much brighter than 5 light bulbs. But however, it will still be equally amount of electrons and protons they're using, because it's from all the same battery. So yeah, that's about it. But also, we're gonna talk about high resistance, low resistance as well, because it's related to electricity. So high resistance is basically no, you can't come in, stay away from me. It's like resisting electrical movement inside of you, alright? So, we're talking about wires to be more precise, alright? So, usually, long, skinny wires, very high resistance, alright? Because, even though it lets electricity move, it's tight. And it's also long, which means you go a long way in a tight space, right? And a lot of electrons they don't go in an orderly line, they go mushy in certain parts, it goes slowly, alright? And for low discharge, alright, off proof, no problem. Which basically means that, it has a lot of space and it's short. Because, let's say at a 4 millimeter thick wire, alright? And, it has a lot of space. And it's not that long, it's 5 centimeters at most, alright? And you connect it, obviously it will be very, very fast. It can go smoothly because even though they're clumping each other, there's still space to keep moving. Which basically means that, obviously, they can just get to the light bulb without much resistance happening. And also, one more thing is that, there's conductors and insulators. Conductors, metal. And a lot of things are metal, A lot of things conduct electricity. Insulators don't conduct electricity. Examples include plastic, glass, but now we've captured glass in a box, so that doesn't count. Wood, and also concrete, because concrete is not a metal; it's a sort of rock, and rocks don't hold electricity. So yeah, that's my video, basically summing up general electricity. Thanks for listening to what I've had to say, and goodbye. Nice day. Please subscribe. These videos do take a lot of time, and I would appreciate it.